All right, so I'm calling this particular program Program 4S since it's going to be a supplemental program to Program 4. So we have already created the Program 4S project folder and created the Program 4S source file, and I've also copied in our problem statement. And I think our problem statement, the way I've expressed it here, is sufficient enough for us to forego the pseudocode. So basically we just need to get the inputted score, and then based off of what range that score falls in, we'll output the appropriate message. So let's go ahead and start coding. So we'll do our includes, pound include, IO stream so that we can do some input and output, and then using namespace standard, and then we can start writing our main function. So int main open paren close paren, open brace, close brace should be inserted automatically for you. Okay, so the first thing that we need to do is get input from the user. And the input that we're going to be getting from the user is an integer value, so that's going to be the score. So we can go ahead and declare and initialize a variable named score of type int. So int score, assignment operator 0, semicolon. And then once we have that variable declared, we can go ahead and prompt the user. So we'll go ahead and do cout and say enter an integer score between 0 and 100. Okay, and we'll put a period /n for new line character and semicolon. So once we have that prompt there, then we can read whatever they input from the keyboard by using cn. So cn, then use the extraction operator, and we'll say, oops, we should put the variable name here, so score. So that's the basic 3 steps we have for getting input from the user. We have to have a variable declared, then we can prompt the user with some sort of message, and then get whatever they inputted and store it into the appropriate variable. So once we have the score, then we can decide what range it falls on and output the appropriate message. So if the score is greater than or equal to 90 and the score is less than or equal to 100, then we would just simply output awesome. So we'll write awesome here and put the exclamation point. All right, maybe new line character 2. All right, so if the score is 90 to 100, we'll output awesome. If the score is greater than or equal to 80 and score is less than or equal to 89, then what do we output? In that case, we output well done. Now, one thing that you'll notice here is whenever I'm writing these Boolean expressions inside of the parentheses here, I'm having to express score in relationship to both the lower bound and the upper bound since I'm writing out both. So it's not good enough just to put score in between 90 and 100. So many of you may be tempted to write this like so. So maybe we have 90 here and then do less than or equal to score, and then that operation there. So that may be the way that you think about it. You're saying, oh, well, you know, score here is greater than or equal to 90, and score is less than or equal to 100. Unfortunately, that particular type of syntax does not work. We have to do it like this. So make sure you're writing it like so. And also that you are, in fact, using the AND operation as opposed to the OR operation. Again, if you tried to use the OR operation, we could write in a score like 1,000, and it would qualify on this condition here. And while that would be, this part would be false, so saying we had an OR here, and that part would be false if it was 1,000, but yet you would still output awesome, and that's not what we'd want to have because it has to be on the range of 90 to 100. All right, so we have that, and let's do AND here. And let's see here. All right, so let's come down and do the next one. So if score is greater than or equal to 70, and score is less than or equal to 79, then what are we going to do? We're going to output average. Okay. And if the score is greater than or equal to 60, and score is less than or equal to 69, we will output bummer. And then finally, if the score is greater than or equal to 0, and score is less than or equal to 59, not 590, but 59, then we would, oops, let's see, I got a mistake here. See out. And see out. We'll do sad times. And that's our basic program here. Again, you can have your return 0 statement here at the end. So return 0. That's not really required. If you don't put it in there, you'll probably get a warning, but it assumes that you're going to return 0 if you don't have that return statement in there. So that's our basic program. Let's go ahead and save this, and then we will build it. Now, you'll see here that we have these red squiggly lines under cout. For some reason or another, the new version of Eclipse CDT, the Indigo version, it seems like the code analyzer is very slow on indexing everything so that these errors are actually removed. Eventually, these things will go away, and I need to do a little bit of research and post why that's occurring. If it's just me and the way I have things set up, or if it's something wrong. I think it's something wrong with the code analyzer. This is a new feature within Eclipse CDT Indigo. So everything built okay down here if we look at our console. So whenever we built the program, it was fine. So let's go ahead and run this and ignore that for now. So it says enter a score between 0 and 100. So let's put in the score of 87. And it outputs well done. Let's do another one. Let's run the program again, and this time we'll enter in 55. And it outputs sad time. So it looks like it's working correctly. Now, one thing that I do want to point out about this program is that we construct each one of these conditions with if statements. So if. So anytime that we have an if statement here, it's going to go in and check each one of those. But we know that if we have a score, and that score is between 0 and 100, it can only fit into one of these conditions. It can only meet one of these conditions. So we're actually doing more checks than we should be doing here. So, for instance, if my score was, say, 100, it will still go in and check each one of these. And we can actually verify that that check is going on by interactively going through this program using the debugger. Before I launch the debugger, I want to make a few code changes. So on our lines where we have these cout statements, you'll notice that they end with this new line character, that /n. I want to get rid of that new line character and then come on the right side of our string literal and do the insertion operator and then endl. And so this endl is what we call an IO manipulator. And it works almost the same as the new line character. So it does, in fact, insert a new line. But the other thing that it does that the new line character, the /n, doesn't do is it flushes the output buffer. And what that means is any characters that we had from, say, the string here that were sitting there in memory waiting to be pushed out to the console will be forced out by this endl operation. So it's basically flushing all those characters, that string there, out to the console. And with the new line character, we don't get that. Now, when we run the program outside of the debugger, we really don't notice a difference. But as we run it, this code through the debugger, or use the debugger to step through this code, then we'll see that if we had the new line character in there, it wouldn't actually push all that text out to the screen as soon as we had executed that line of code. So on all these lines here, we'll go in and change this to indel, and you can do the same. Actually, I may do some copying and pasting here, make it a little bit quicker.